Thank you. Thank you for reminding me. Okay, so the first concept when it comes to memory optimization is called aliasing, okay? So aliasing means that we are assigning the value of one variable to another. So suppose that I have like a string called Isaac, and it's stored at a variable name called first. And then I made this aliasing at which I made the like the first to equal to the second, okay? So what does that mean? That means both of them, because we remember in Python, you know, like the value will determine the object type, not the not the inverse. So both of them, they're gonna point to the same value on the memory, okay? Now, if and we have already covered that, but now the thing is, what if I did a concatenation here at which I added the last name for the variable first? So variable first now will be pointing to Isaac Newton. Meanwhile, second will continue to point to Isaac. Why? Because remember, what? Strings are what, guys?
Immutable.
Immutable. All right, but what about list? Okay, so suppose that I have like a list, and the list has one item called Isaac, okay? And as you can see that, and then I created an aliasing at which I made the first equal to second. Then I did an append, and you know what does it mean, the append? So the append here, append Newton to a list. That means you're adding what? You're adding Newton as a second item to what? To the first, okay? But there is an interesting point, if you can catch here, which is both first and second will continue to point to the same value in the memory. So if I print first, it's gonna give me Isaac Newton. Meanwhile, if please note that I did not change anything, okay? So if I print second, it's gonna still give me Isaac Newton. So what does that mean? That means that when it comes to the list, I don't need to explicitly modify the alias version of a variable, okay? So to understand that better, let's take a look at this. And you know what? I want to do it with you, like on Python, on the visualizer, okay? So this is a simple program at which what we are doing, we are creating a list here, 1, 2, 3, and it's referenced by a global variable called A, you know? And then we're doing the same for what? For B, okay? Now the thing is, if I try to evaluate A is equal to B, what does it give me, guys? Does A equal to B?
Yeah, I'll give you true.
It's gonna give you true. What about 4? What does it mean? A is B.
False.
Why false?
While these two look
A equals B,
they're not actually the same thing.
Okay, A is B. What does it mean?
it's the same as A equals B.
It means that A and B occupy the same space in the memory.
Exactly. Thank you so much. Who did answer this?
Me.
What's your name? Oh, David?
Yes.
Thank you, David. So what does it mean? That means we are checking if A and B are stored at the same location in the memory. This will gonna give me what? False, sorry. Because what we did here, is we have declared two different variables in what? In the memory, okay? A and B, okay? We did not do any aliasing. Did we?
We did no aliasing.
Not yet. We did not do any aliasing. So the value of A equal to the value of B, okay? But the value of A are stored in a different memory location than the value of B, okay? So now Look, what I did an aliasing at which I made C to point to the same location as what? As you can see, guys, here, like A is pointing to a location and B is pointing to another location. All right. Now, when I did the aliasing, both A and C are pointing to the same location in the memory, and they're having the same value. Now, look what I did here. Now, I did another aliasing at which I aliased A and B. So what does that mean here? That means A will no longer point to this, to this location in the memory here. It's gonna point to this location in the memory. That's exactly what happened. Now, if I did A is B, is it gonna give me true or false?
True.
True.
True. Why? Because they're pointing to the same location in the memory, okay? So that's exactly what's giving me true. Now, if I change the value of the first item in A, what does that mean?
It should change the value for B as well.
Thank you. So both A and B will have a new first item in the list will equal to what? 100. Now, if I print A, B, and C, what's gonna print? It's gonna print 100, 2, 3 for A, 100, 2, 3 for B, and 1, 2, 3 for C. Clear, guys? Anybody has a question?
Sir,
Yeah.
if C is equal to A, then why isn't the 0 for C 100?
No, we just moved it. Okay, you have to follow each step carefully. So let's go back here. Okay, so we have created. Okay, let's go from the beginning. We created A and we created B. Both of them, they have the same value, but they are pointing in different locations in the memory. Okay. Then after that, we print if their values are equal to each other, which is the case. However, at the memory, they are in different type of the memory. I'm going to show you in a second. What do I mean in different places in the memory? Now, so because they are not at the same place in the memory, I'm getting false. Now, what I did here, I did some aliasing at which I made C to point to the value of A. You see that? Okay, but at the same time, I changed the value of B. I changed the value of A to point to the location in the memory that is assigned to the variable B.
Okay.
Look at this at line 6. Okay. So now C is pointing to a location, and both A and B are pointing to a different location. Okay.
Yes, I understand now. Thank you.
Okay. All right. So anybody has a question?
If you made B0 equal 100, would it have the same result?
What do you think?
I'm assuming yes.
What if that's not the case? What does that mean? That means I'm a bad teacher, because it is the case.
Wait, that just doesn't make sense.
Why
Yeah,
does it make sense? So you're changing the value of B 0, which is pointing to the first item here. And this will be reflected to A as well. Okay. Does it make sense to you now?
Yes,
Yeah,
you're a
yeah.
good teacher. That's what I meant.
Thank you. Okay, by the way, guys, that was one of the questions in the midterm 2018. Okay. Okay, so let's go back and okay, so in a nutshell, so when we are not doing aliasing, we are assigning the same value to different variables, okay? And when we are doing aliasing, we are assigning the value of one variable to another, okay? So why we're complicating our things, okay? Why we're doing the aliasing?
To make them separate them, I guess, or
Okay, why we are complicating things with aliasing, you know? That's what I mean.
Maybe so
So
that
whenever
the
you change-
value of first and second, like they get updated as you change one.
Exactly. Thank you so much. You know, like for the student who answered this. So this is for optimization. As we mentioned, the main goal of this class is to understand the memory optimization. So instead, if you have a list that has 1 million of items, okay, you know, and like you created another list, okay? So if you want to change the first 50,000 items, do you need to go to each list and change it? No. If you did the aliasing, that means anything you have done to the first variable will be mirrored to the second variable, okay? Clear?
Yes.
Okay. All right, so let's recall the object type that we have covered so far. So we have covered the what? They covered the integer, the integer, the float, the Boolean, and we've covered the list, the string, and the tuple, okay? The thing that we did not cover yet is the dictionaries and sets, and we're gonna cover it later on, okay? Plus, there is some kind of object types that are for the complicated numbers. I did not cover it, and we didn't need to cover it. So what, like, when we say the value can be changed, we mean changed in the same memory address, okay? So that is exactly what does it mean, immutable or immutable, okay? So we said that the integer is immutable because we cannot change the value. When we change a value of when we change a value of a variable that is belonging to the integer class type, we will point to a new location in the memory, as I'm going to show you, okay? And the same applies for string. The same applies for float. The same applies for what? For tuples. Okay, so the integers are immutable, floats are immutable, Boolean are immutable. The complex, we did not cover it. Frozen set, we will not cover it, okay? The set are what? And the dictionaries and the lists are the only type, the only data type that are be considered as immutable objects. What does that mean? That means that I can do aliasing on it. Well, that means that both of them, they're pointing to the same value in the memory, okay? So, okay, but how can we tell, okay? So actually, we can use a combination of two functions. The first function you saw with the is, you know, and the second, the is operator, and the second function is the ID function, okay? So the ID function retains the object memory address, and the is returned true if and only if the two objects have the same memory address, okay? So say that, look, at x equal to 5, and then I did idx. What does that? This will give you the address like of a variable x in the memory, okay? Of the value of variable x in the memory. And this will differ, you know, from my computer to yours, you know, based on the specs of the hardware that you have. Now I change the value using the shortcut notation, and x now is equal to 6. If I take a look at the address again, it's going to change. Okay, same applies to what? To string. You see here, so the real Python was stored in the in the variable s, and if I try to get the address in the memory in a decimal value, we will see that it's in a given address. I did that like a concatenation. And here, guys, when I'm doing this, that doesn't mean I'm changing the value of S. That means I'm doing a concatenation that's equal S equal to S plus the new string. And this is allowed. However, we cannot modify a character inside what the string. Okay. And now what we're going to see is when we're going to do IDS, it's going to give us what? 24. All right. Like 24, which is the new address. This is what I meant. 9424. Okay. Nathan, what's your question?
I just had a question for the memory location. Is it like random, assigned randomly to a specific place, or is there a way to find out where the memory, like where the data is stored?
Yeah, this is outside the scope of this course. You know, there is something called the stack,
okay.
and the compiler will talk to the stack. So, but there is nothing called random. Okay.
Oh, okay, thank you.
Okay. But for us in this course, yes, it's random. Okay.
All right, thank you.
Okay. So let's take a look at an example at which I'll explain things properly. Okay. Now, suppose that I have A equal to 2000 and B equal to 2000. Okay. You see that A is stored in a location in the memory. This is a hexadecimal location, X2, like, you know, to denote that this is the RAM. And it's like more like a bookshelf. Okay. That's the index and that's the value itself. So A now is here and B is here. Okay. And I did C equal to what? A plus B. So C will equal to what? To 4000. Okay. So what does that mean? That means, you know, if I do like is A if A equal B, the value will be true because the value of 2000 is stored in both A and B. But if does A or A is B, the answer is false because as we can see, we have different we're storing the value of A and B in different locations in the memory. Now, let's suppose that I did the following thing, okay? Now, I did A equal to A plus B, okay? So what does that mean? That means A will no longer point here, okay? And A will point where? To a new value that is equal to 4000, you know? And it's what? 209. Okay, but who's gonna take care of this? Like, you know, like, because the bookshelf will be like, if we are doing this all the time, who's going to take care of what was the value here? That value is floating now. There is something called a garbage collector that will make sure that will empty that stack. Okay. So let's take a look at at the function ID again and is again. So as you can see, A, I made it equal to like this big number, okay? And B, and for purpose, I did it to like, you know, to be like for this number because I'm gonna like tell you exactly what's going on. So the function A equal, if I did A equal B, this is gonna give me true, okay? But if I did A is B, this is gonna give me false. Because as I mentioned, both of them will be in different location, okay? Now, if I print the ID of A, as you can see, this is what the memory location at which the value of A is stored. And the value of B will be different. That's why when I did A is B, it gives me false, okay? So, like, let's take a look at this example. Create a Python object at which we like create the Python object 1000. So it's an integer, assign X to it. Okay. So create X equal to 1000. Python object 499 Y. And if I add both of them together, they will have the same value, but If I do the is, they will not be at the same memory location. But don't you think that this is a wasteful? Don't you think that Python is wasting the spaces in the memory, knowing that y and x, they have the same value?
No.
Why no? If you answered yes, why? If you answered no, again, why?
No, because you can be using the numbers for different equations, so they need to be separate.
Yeah, same reasoning here.
Okay, Alexander.
It is wasteful, but won't the compiler catch that? And when it optimizes the code, say, hey, these things do the same thing, and it'll just adjust the pointers in the background?
That's the case in the C, not in Python.
Okay.
Or like your answer is partially correct. So as he mentioned, your mate, he said that the interpreter will make sure that, you know, like all those floating values, you know, will be discarded whenever I change the value of a variable. Okay. However, in Python, there is something called interning. If you notice, all my examples are numbers that are larger than 256. So what does it mean, interning? Interning is reusing the objects on demand instead of creating a new object. So when we do like an integer interning, look at this, because if the integers, they fall between -5 and 256, they will be interned. So what does it mean? That means, you know, Python will assign the same memory location for X and Y in the memory. That's why when I do X is Y, it's gonna give me true. Okay. And the same thing applies for the string. So if your string contains only the ASCII characters, digits or underscore, that exclude the space as well. Okay. So if we have a space, the interning will not work. Okay. So if like your both strings, they contain the same ASCII digit and underscore, they will be interned. What does that mean? They will have the same value in the memory. Okay. So why do we have interning in Python? Because it's a memory optimization technique. Because let's suppose that we have 1 million of strings here, okay? 1 million of characters here. And if I want to do the comparison, okay, operator between both of them, Python will do what, guys? Python will compare each, you remember, each single character in the string. However, since we know that this is an interned string, we're going to compare the location of the memory, and we will say that, okay, S1 is equal to S2. Okay. However, it's not the case when when I have a space or when I insert the special character. So as we can see, both of them, they're going to give me false. Okay, to understand it better, let's take a look on a visualization. So if I have a that is ranging between number that is ranging between -5 to 256, both of them will be referenced at the same memory address. Okay. If we increase it by only 255, then those values will not be interned anymore. Okay. The same applies for the, you know, you see that if I increase it by, I make it like a equal to thousands, it's going to be in a different memory address, even though both of them, they have the same values. Now, why did we choose -5 to 256? This is the way that the stack is implemented in Python. And again, it is outside the scope of this course. However, these values can be modified, okay? All right. Okay. So I think like I explained this properly. And now I believe you guys, you know the difference between what? Between the equality as well as what the is operation. Okay? When it comes to the integer. Am I right? So do you have any question regarding this slide?
I have one about the previous question. Well, like the interning bit.
Yeah, here?
Yeah, so we have x equals 20, and then we have y is equal to 19 plus 1. If we just did x equals 20 and y equals 20, and then said x equals y, do we still get true?
Well, try it. The
Okay.
answer is yes, but try it.
Yep.
Was it the case?
Yes.
Okay. All right, what about this? Do you have any question? Here it's the same thing, whatever I explained, you know? So, okay, let me re-explain it. So I have a value of A equal to, like, suppose this number is 1,000,000, okay? And it's stored here in the memory. Now here what I did is an aliasing. So both C and A are pointing to the same memory location. You know what I mean? So now if I did A, C equal to A, that's yes, because the value of A is literally equal to the value of C. And are they pointing to the same place in the memory? Exactly, that's the case. Now, I change the value of A, okay? And now the value of A will no longer point to this location in the memory, it's gonna point here. Now, are they equal to each other? No. Are they equal to what? To like are they like in the same memory location? The answer is no. But that's not the case when it comes to what? To mutable objects such as the lists. Okay, so A is a list that has 1, 2, 3, 4, and it's here in the memory. That's it in the memory, okay? And then I did an aliasing with like I did alias 8 with C. Therefore, what's gonna happen? Both of them, they're gonna point to the same memory location and the same value. Now, if I check, like if they're equal to each other, it's gonna give me true, true. Now, if I change the value of C, the same thing will be pointed to what? The same thing, the same changes will be reflected on A again. Okay? And if I print them, they will have the same thing. Now, the question is, what would happen if I did A0 instead of C0? And we have just covered it. What will happen? Answer me.
No difference.
No difference. Thank you so much. Okay. All right. Now, let's take a look on this example. And literally, this function is doing nothing. Okay. So it's take a list as an input, modify the first item, and that's it. Okay. So like the interpreter will do the following. Read, this is a function definition. We'll skip it. Go here, create what? Create a global frame or a global variable that has 100, 200, and 300, and then print it. So when we print it, it's going to print 100, 200, 300. Then I did call function foo and replace the input argument with the value of my list here. And because lists are mutable, what's going to happen? It's going to change the first item, and it will be reflected when I come back from what? From that function, okay? So if I print it again, it's supposed to print what? It's supposed to print, because I've changed it to like 123, so it's going to print 123, 200, 300. But if we did the same thing with integers, whenever we get outside the scope of this function, the value that is defined at the global level will continue to be the same. Okay? Okay, so in Python, are we passing the variables by reference or by values? Okay, let me reformulate my question. So in Python, do we care about the name of the variable, or we care about the reference and the type of that variable?
The reference and the type.
Exactly. So in Python, it's more done by passing the reference. So whatever like stored in that location, because the guys, you know, at the end of the day, I want to know the location as well as the value here. Okay. And those will determine what? Will determine the type of the object. Okay. And, you know, and it's based on the memory location, what's gonna, you know, what is I'm passing. Okay. Not based on the value itself. Okay. Okay, now let's take a look at the tuple. If you remember the tuple, so the tuple is a special type of list at which you can declare it, you know, declare multiple items using the comma, and the parentheses here, the regular parentheses or the brackets here are what? Optional. Okay. Okay, which are different from the list, which are what, guys? The lists are declared using the square brackets. So if I print type A, type B, this is a tuple, this is a list. Okay, print the length of A. Okay, the length of A is 3, and the length of B is 3 again. Okay, now if I did B equal to 100 and print B, this is gonna give me what? It's gonna change the first item without any problem. However, if I try to modify the value of the tuple, I'm gonna get what? I'm gonna get a problem because I can't modify the tuple value. Okay, tuples are immutable. You can't change the value of the item contained in them. Okay. All right. So again, let's take a look at the difference between the immutable and immutable objects. So I have text, not sure if this is immutable, and print the ID of this text, the ID of the text of that string. Okay, so that's it. Then I did a concatenation at which the text will be equal to whatever I have before plus what do you think? Okay, and if I take a look at the memory location, it's gonna be different because text will no longer point to this, to the memory location that contains this value of the string. It's gonna, you know, it's gonna point to the memory location that has both of them. Not sure if this is immutable plus what do you think? Okay, now the case is different when it comes to mutable, because even if I change the value of the mutable, it will still continue to be at the same memory location. Is that clear, guys? So do you understand what is going on in the memory now?
Yeah.
All right. Okay, so now let's move to another topic, you know, that will help you for solving assignment 4. Okay.
I just have one question.
Yeah.
So basically, in this case, Python checks first the type of the type and see if it's mutable or not. And if it's mutable, it stays the same. But if it's not mutable, the location will change.
Can you say it again?
Okay, so for example, here when for the list,
yeah,
when we appended 4,
yeah,
and the location did not change, right?
Yeah, because remember
because it's mutable.
Yeah, because remember, first of all, Python what will do is will take a look at this side of the assignment operation, and this is a list, and will point it to X. Okay.
Mm-hmm.
And this will be in an address in the memory. Okay.
Yeah.
Now, when I did IDX, I'm printing that address, okay? And
Okay.
since this is a list, okay? So anything I'm doing that will be what? Will be at the same address.
Oh, okay. Yeah,
Okay.
so basically it checks if it's mutable or not also, right?
Yes, yes. In other ways, yes. Yeah, like you can say it this way. Yeah, it's correct.
Okay, thank you.
But recall, the value will determine the object type.
Okay, gotcha.
You got me? Because I can here write x equal to tuple 1, 2, 3. And the value in this x will no longer be pointed in the memory. Okay?
Okay.
It will be up to the garbage collector to delete it. Okay?
Yeah.
All right. So let's cover something called randomness and random sampling. So can you tell me what is randomness, guys? Who has an idea about what does it mean randomness? In real life, what does it mean randomness?
Something that we can predict.
Thank you so much. That's something that is very hard to be predicted, or you can't predict, you know? So, okay, why do we need like this kind of thing, you know?
To play a game with the computer.
Amazing. So some apps or some application, they need like some probability of distribution, okay? This applies to computer games. This applies to cryptography because you don't want the hacker to understand the way that you're ciphering your text, okay? As well as, you know, like to capture some kind of a simulation, you know? So what if, instead of trying it, no, you can create a random instance, and this instance will check your your simulation. And that's why random numbers are useful for running simulation in science, engineering, and finance. They are needed in modern cryptography protocols that provide computer security as well as privacy and authentication. Okay. So, and as well as like guys, you know, like I am assuming that you know the poker or the blackjack, you know. So if we want to shovel the deck of those cards, we want to shovel it in a random way. Okay, so we would like to make the computer games more excited, more entertained. As such, you know, we will make it less predictable. That's why we are using randomness. But quite frankly, like truly random numbers are hard to generate. You know, there is like, you know, there is no such an algorithm in life that will provide you what? Like a true, like random numbers. Because at the end of the day, it has this, like this program that provides the random operator, the random numbers or the random assignments. It has been written by a human, and that human, he did some steps to make them random. So if we catch those steps or catch that algorithm, you know, it's no longer random, okay? Therefore, in programming language, you know, you will encounter this kind of terminology. It's a pseudo-random number generator, okay? What does it mean, pseudo?
Like not fully?
What?
Like not really, it's not completely random.
It's fake, it's not real, okay? Okay, so the numbers will appear to be random, but the guy who wrote the random library knows exactly how those numbers are generated, okay? So in Python, similar to the what? Similar to the math library, in Python, we can use the random library to provide the random, the pseudo-random generators, as well as sampling functions. So to understand that, let's take a look on the examples here. So suppose that I would like to generate a number. That number, you know, has two ranges, A and B. So if I did random to like what? Why? Because you remember to the math. Whenever I would like to call a function from the math library, we will reference it first. Okay. So random dot, then the function name, which is random range 1 to 7. What does that mean? That I'm gonna return a number. That number will be randomly generated, or like pseudo randomly generated, between 1 and 7, and 7 is not included. Okay. Okay, and as you can see, it gives me 2. If you try it yourself, it might give you 1, it might give you 2, it might give you 3, up to what? Up to 6. Okay, and each time you're running it, you will have a different, okay guys, a different like a different answer. What does that resemble? Can you like try to to find a correlation between this and a metaphor in life?
Could you please repeat the question, please?
Okay, so this line of code, why can I okay, okay, just give me a second. Okay, this line of code, guys, can be useful to resemble something in real life. Like what?
Rolling the dice.
Rolling the dice, exactly. So this can be used to simulate the throwing of the dice. Okay. Now, let's suppose that we would like to include, you know, both numbers that are in the bracket. So what kind of function we can use? Instead of rand range, we can use something, some other function called what? Called rand uniform. Rand integer. Sorry, rand integer. So if we take a look at, where is that? Python tutor. Okay. And if I say here, here, okay. So if I did rand integer 3 to 9, it's gonna return a number between 3 and 9, and both are included. Okay. To check that, let me do the following. So it returned the 3. If I did it again, it returned 5. If I did it again, it's 5. We don't know exactly what's going to happen. Okay, 6. What did I do? 7. Yeah. Okay. So each time it's returning something that is what? That is ranging between 3 and 9. And if I wanna just like stick with the rand range, the threshold here will not be met. Okay. So it's gonna return, if I did instead of rand integer rand range, it's gonna give me what? The numbers that range from 3 up to 9, and 9 is not included. Meanwhile, rand integer is going to give me an integer number that belongs to the interval of 3 and 9. Okay. Now, that is for integer types. What if I would like to have a float? Okay. So if I would like to have a random float number, then in this case, I'm gonna have what? Use the uniform. And at the uniform, I will specify that the beginning is 0 and the end is 1. Therefore, I'm gonna return numbers, okay, that range from 0 to 1, and both of them are included. So, so this function might return 0 and this function might return 1. But most probably, because we have a lot of, you know, like numbers to cover, it's gonna return a float number, you know, that is located between 0 and 1. Now, suppose, guys, I just want to have, instead of having those long numbers, I want to have just, you know, 3 decimal digits here. What should I do? I would like some interaction. If you will not help me here, I'm not going to help you at the exams.
Use round.
What? Use round, exactly. So we can import math and we can use the round, okay? That's it. And the round will determine how many decimal digits that we need to use, okay? Now, we covered how we can get a random integer, okay, using the rand integer and the rand range, and how we can cover what, how we can get a random float. Now, suppose that I would like to, you know, to do a random over a sequence, okay? So I have three useful functions. Those functions, you know, can be used to, instead of, you know, like producing a number, you know, it can be like rearrange your sequence. That sequence can be a list, can be a set, or whatever, you know, and then reproduce it again. So the function shovel, okay, what will do, it will rearrange the object in the sequence, okay, like the way that, you know, the cards are shoveled in a blackjack game, okay? The function choice allows us to choose, choice, to choose an item from that container, which is in our, like in our, up to now, it's the list, okay? In a uniformly random way, okay? So instead, if we would like, if we would like to get like some sub items randomly from the list, we'll use the function sample. Okay, let's take a look on some like example. Suppose that I have names here, and then I shoveled them. So as you can see, the way that those names are rearranged in a random way. Okay, now suppose that I did choice now, okay? Choice name, it gave me Pop. Choice name, it's gonna give me what? Anne. Choice name, it's give me Cal. Again, it's give me Cal, but that's not that, yeah, like that's not guaranteed, okay? So the choice will choose an item from this list and will return it, okay? Now, for function sample, the function sample, suppose that I want to return like a list that has 3 items, okay? And randomly picked up. So I will use the function sample, okay? And I will determine what the sample size. And then I'm gonna get what? 3 items from this list in a random way. Is that clear? Clear or not clear?
It's clear.
Okay, so now let's take a look at like a real life example. Okay, so we would like to implement a function, guess, that takes an input integer n and implements a simple interactive number guessing game. The function should start by choosing a random number in a range from 0 up to not including n. So that means you have to use the rand range, okay, instead of the rand integer. Or you can use the rand integer to n minus 1. The function will then repeatedly ask the user to guess the chosen number. So what does that mean, guys? That's an infinite loop. You know, when the user guesses correctly, the function should print "you got it," and message and terminate. Each time the user guesses incorrectly, the function should help the user by printing message "too low, too high." Can we implement this kind of function?
Yes.
Okay, so what's your philosophy? What's the algorithm that you're gonna use?
Since it's an infinite loop, we need to use while.
While it's true, yeah?
Yeah. While it's true, we need to call the function random.
Okay.
That gives a number between 0 and n.
Okay.
And if the guess is true, you got it. And if it's not true, it repeats the loop.
Repeat the loop. Thank you so much. So his answer is like 80% correct. So the way that, remember, we have to rewrite this kind of of a problem in a Python syntax way. So first, you know, like we have to import the random library. Why? Because we need to use a function that provides us a random integer, okay? And then after defining the function as stipulated in the, or as specified in the exercise, we will define a name, and that name will the variable name will name it secret, okay? And we will create that secret. It's one time at which I'm gonna create a random number from 0 to what? To n. And n is not included, okay? So if I did guess 100, that means from 0 to 99. So now I generate the secret number. Now, while it's true, okay? While it's true, I'm gonna ask the user to guess. You see that? Then the function will then repeatedly ask the user to guess the chosen number. So I have to use input, guess your what? Your enter your guess, because it says, you know, it says that the user have to be provided with some kind of helper like message, and if the guess is equal to the secret, I'm gonna print "you got it" and break. What does the break will do here? Will exit the loop. Else if guess is less than secret, I'm gonna print what? Too low. Else, that means that guess is greater than secret, or it's not the case of less than secret or equal secret. So it's exactly, it's guess is greater than secret. I'm gonna print too high. Is it hard?
No.
Okay. So I believe we're done, the class.
Yeah, we're done.
Yeah.
So any question, guys?
Sorry, sir, for the last function, why did you use eval?
Okay, you can do as integer instead.
Okay, thank you.
Okay.
What's the difference between eval and integer?
Eval is more powerful. So eval, if you remember, eval will, based on whatever you entered here, if you entered 5.1, it's gonna convert it to a float.
Oh, so it's mostly an integer, but in the case it's not an integer, it gives you a string.
Yeah.
I'm sorry, not a string. Float. Yeah, all right, thanks.
Yeah. And even if you eval will work even with if you enter true, it's gonna convert it right away to a Boolean. Okay.
Okay. Yeah. All right. So it's automatic.
Yeah.
Professor.
Yeah.
During the reading week, will we be able to ask questions in the discussions thing or no?
Okay. What do you think? What do you think?
I hope so.
The answer is yes.
Yeah. And can we go over assignment number 4 a little bit on the next
lecture for sure? Yeah.
Yeah. Thank you so much.
Okay. So I was planning to give you like another challenging question, but I don't have time. Okay, but I'm gonna explain it later on. So like another way that I don't wanna do it an infinite way. I wanna do it with like, you know, like more like Vida style, okay? But we'll keep it to the next lecture, okay?
Okay.
Okay, guys. So anybody else has a question?
Yeah, I had a question.
Ali,
Yeah,
how was your exam?
the exam was good. It was not that hard. It was easy, but only question one, you said the first examples and then the last example when I have gotten correct, but in the middle, I didn't have time to like check all of them. I
Okay.
just checked some random numbers.
Okay, don't worry, Ali.
Okay, no problem, but all of it was easy. It was not hard.
Okay, Ali. I miss you, man. I miss your voice.
The question I was asking was like, most of the instructions, maybe in the assignment or even in the test, they were saying you cannot call a global variable inside your function, your definition function. But some questions were telling us to call a function. Like the
function?
like the last question, it was saying you have to make a call to the function helper.
Helper, the helper function. Okay, no. So, okay, let me tell you exactly. Do you remember the assignment 1?
Yeah.
Or assignment 2, at which you build the CAT payment?
Yeah.
And then to get the loonies and the toonies and the stuff, you have called that function?
Yeah.
So that means that the CAT payment is a helper function.
Oh, then it has no problem. We have to just follow the instructions.
Exactly. So what does that mean in the question 3 of the test? You have first to develop the helper function and then use it inside the body of the second function.
Oh, that was
I don't know, like choose. I don't even know how to pronounce the function name.
Oh, the other functions was like RE or something, AR something.
Yeah, R something. Okay.
I have called the function helper inside my def function, but I was like, because in the first instruction they were saying you cannot call a global variable.
No, you cannot use a global variable. Did anybody still ambiguous? Did anybody still have any ambiguity about the global variable? Do you know what's a global variable? Yes, Ali. You know what's a global variable?
Yeah, global variable. I thought like it is something maybe when you assign or when you like the A is now global variable.
Thank you, Ali. Ali, you're the best, man. You know, A. You see that? And A equal to what? To 5. That's it. Okay?
I think you need columns.
Yeah, I need column here. Okay, A equal to 5. Okay. And then nothing else, nothing fancy. That's it. That's my program. Now let's take a look at this program. Where's the visualizer? Okay, Ali, and this is the, you know, the console. Okay.
Okay.
And here we are print A. Okay. Now print Ali. Okay. Now, okay, I want to print. Okay. A equal to 5. A equal. I'm gonna make it 7. And let me make a return here. Okay. I hate this indentation. You know, because I'm not doing anything like this. Now print A. Print.
I think you should change line 12 also.
No, I'm good. I'm good.
Oh,
So let's
sorry,
visualize it.
there's
What?
an parentheses
Where?
on the last print statement.
Oh, yeah. Thank you. Okay, so close. So you see that A is equal to 10. This is a global variable. And now, oh my God, I did what, and now I defined Ali. I'm not gonna go and ask Ali, okay? Ali will not be executed. However, I'm gonna go to here, to 8. And at 8, I'm gonna print A, which is 10, okay? Now, like, I'm gonna print Ali A. So even though like I sent a value of A equal to 10, it's gonna be equal to 5, okay? So what's gonna happen? What will I'm gonna print? I'm gonna print 5, okay? Now, if I did here, sorry, like okay, I need to customize it more. Edit the code. If I did print A again here, Ali.
It will be 10.
Yeah, so I'm gonna print 5. That's, I know that. Why? For this line 9, because the value of the return will be placed in 9 here. Now, if I print A, what's gonna print?
10.
10 or 5?
10, because A is equal to 10.
Because A is defined in the global scope as 10. And the function, Ali, has no control over A.
Yeah.
You see that?
Yeah.
Okay. And again, now it's gonna print 5 again. Okay. Clear?
Okay. Yeah, but now the thing is, under global variables, we have two names, A and Ali. Now you can see like Ali is now a global, inside global variable. If I define
Ali
another,
itself as a function is a global variable. Exactly.
yeah, then if I have to define another function and I have to call Ali, I have called a global variable inside my new function.
Yeah, that's correct. Okay, I'm gonna explain that. Okay, don't worry about it. You know, I'm gonna explain it. Okay, yeah, like those things that you are referring to is coming. I don't know which lecture. I think, yeah, I think it's here. I think here, Ali. Here, but not for this lecture. And where's the Zoom? So you see that, Ali? I have multiple functions, they're calling each other.
Yeah.
So I have a stack that will keep tracing, okay? So whenever I called FR, it's a scope for, and like, you know, for F. And at F, I'm printing start F, and then I'm calling G, okay? At G here, you see, Gn minus 1, which is what I'm gonna do is G of 3, you know? Then I'm gonna go to G. And then at G, I have another scope, okay? Then I'm gonna print start G, and then what? As you can see, I have what? Hn minus 1, which is a 3 minus 1 is gonna be 2, okay? Then at H2, what I'm gonna print start H, then I'm gonna print half, okay? And then after this, what I'm gonna print, okay? Like exactly what's, like you see that? It's like it print half, then 2. Then after that, what's gonna happen is I'm gonna return back where? To the function that called me. So what function called H is what? J. Okay?
Yeah.
So what is the value of N that I'm gonna print?
2.
Here. No, I print half 2. Then after that, I'm gonna return back. Okay, then I'm gonna return back to what? To J. And J, what is the value of N that used to be? 3. Am I right?
Yeah.
So therefore, I'm gonna print 3. You see that?
Yeah.
Then I'm gonna what? And like which function called me here? I'm done J. Which function called J?
F.
Is F. Then I'm gonna print F. What is the value of N here?
3 minus 1.
No. Remember, what is the value of N? Print N. Here, this line. So what I'm gonna print?
4.
4. Thank you. That's it. And if I defined N as a global variable 5 here, and I did print like N, it's gonna be printed 5. Okay?
Yeah.
All right, like this is not for today, okay?
Okay.
Not for today, class. Okay, who has another question? Avinish?
Yeah, it's Avnish.
Avinish.
Yeah, so I unfortunately used dot replace and I just knew that I couldn't do that in number 5 for assignment 3.
In assignment 3, number 5, you did not do what?
I used dot replace the string. Am I going to lose all the points for that?
No. Okay.
And then how are you going to assess that?
I'm going to advise the TA. Okay.
Okay, no worries. Thank you, sir.
Bye.
Bye.
Bye. Paris,
Hello,
how are you?
I'm good. How are you?
You good? You're okay? Did you understand the lecture today?
I did.
And I gave you what you asked me for, yeah?
Which was what exactly? I can't remember.
Which was the thing that you asked for at the exam.
Oh, yes, you did.
Yeah. Okay. Do you have any question today, Paris?
No, I was just listening, but thank you.
No problem. All right, guys. Do you have any question?
I have a question about just the office hours again. I was just wondering.
Yeah, you stay until the end.
Okay.
Okay. Yeah, I remember you showed it. Yeah. Everybody else. So please leave the meeting.
Actually, I want to ask you just like a question about assignment 4, question 2. So can you just quickly explain?
Not today.
Oh. Okay.
I'm not gonna explain something that I didn't cover it properly. Okay.
It's okay. Like I tried to solve it, but like I just confused what we are meant to do. Like what's like the condition, because like it said the list has at least one run, which makes me like I didn't understand what that means.
Okay, can you ask your question again, please?
Yeah, like the question is, like we have a function called toLength run that takes a list of number as input parameters and return true if the given list has at least one run and false otherwise. I couldn't understand this line. So for example, like the input is 1 separated by spaces, then 4 space 3 space 3 space 4. So it should return true, but like in the other example, it is the same thing and return false. So like I couldn't understand what's our condition here.
Just give me a question. You mean like part 4, yeah?
Assignment 4, question 2.
Assignment 2, question 2.
Assignment 4.
Assignment 4.
Yeah.
Yeah, you need to understand what does it mean, the run. So the run means at least a length of 2. Okay. You know?
I don't.
No. Listen. If the list has what? Has a length of 2, you know, then the function should return true.
Oh, okay. So it's basically if it's more than 1 digit.
Exactly.
Oh, okay. That's great. Thank you very much.
You're welcome. Okay. Okay, so everybody else, do you have a question? No? Bye. Remove. And let's do it by. Okay, I'm gonna stop. Is it private?
Kind of. I don't really think so though.
Okay, let me stop recording.